Okay, so I have just explained to you what are the notations that we will be using and what relative velocity is and how do we use the relative velocity. Now we are trying to figure out how to find the relative velocity of one object with respect to another. So let's say that I have an object A that is moving with a velocity of VA, and I have another object B which is moving with a velocity of VB. And since it is not told with respect to what, we will take it as with respect to the Earth, right? So if I ask you to find the velocity of A with respect to B, which is VAB, then you can pretend like we are inserting a letter E in the middle, right? Because we have only three objects, usually three objects are involved, two objects and a common reference frame, right? So if I insert the letter E in between, I would get VA and the E, that means the velocity of A with respect to E, and I would get, now that I have inserted E, E will be in the front of B, right? Velocity of Earth with respect to the B, right? So this is the standard equation that we will use to find a relative velocity of one object with respect to the other. Because we know VAE, we know VBE, but we do not know what this VEB is, which is the velocity of Earth with respect to the B. So in vectors that we learned in the first lesson, if a vector is pointing right, and if we call it a positive vector, right, by a notation V, so let's say VBE. So that is the vector of velocity B with respect to the Earth. The same vector, which is of same length, but on the opposite side, is considered a negative vector, and we will call it VBB, right? So in general, the VBE is negative of VEB. That means the velocity of the B with respect to the Earth is negative of the velocity of Earth with respect to the B. So I can give you one simple example that you can relate here as well. So I mentioned that if you are traveling in a vehicle and if you look outside, everything seems to be traveling on the opposite direction, but you are the one who is actually traveling forward. So if I say that you are traveling at a speed of 10 kilometers per hour, but if you look outside, all the buildings and the trees and everything seem to be traveling at the same speed, but in the backward direction, right? So that is where this negative is coming from, or that is the understanding of this negative value. So if I take moving right as positive or moving to the right as positive, moving to the left will be taken as negative, right? So that is exactly this conversion, right? So this VEB, I can write it as negative of VBE. So my VAB, which is the velocity of A with respect to the B, is velocity of A with respect to the Earth minus the velocity of B with respect to the Earth. Now that I have converted this to this equation, I know what VAE is and I know what VBE is. So I can find the relative velocity of A with respect to B, or you can even find the velocity of B with respect to A. In that case, you will get VBE minus of VAE, right? So this is nothing but the negative of what you have right here, right? So this is the negative of what you have right there. So I can write it as minus VAB, right? So VBA is negative of VAB. So this is what I explained earlier in the previous note. So I'm going back. So I mentioned that one person is traveling at a speed of 4, the other person is traveling at a speed of 6, right? After a while, this person who is traveling at the speed of 6 will be leading the other person. So when the slower person looks at the other guy or girl, that person is moving forward, right? But when the other guy looks at the slower person, that person will be looking, or he will perceive that guy to be moving backwards. So this is a negative and positive thing. So moving forward, if I take it as a positive, moving backward, I should take it as a negative. So that is the reason why I said that the velocity of B with respect to the Earth, not the Earth, velocity of B with respect to the A is a positive value because that person is leading, and velocity of A with respect to the B is a negative value because that person is lagging, right? So this is what we call a leading, and this is what we call lagging, right? I hope that makes sense, right? So in this lesson, we have studied how we can find the relative velocity of one object with respect to the other object while the individual velocities are given, right? So these values are given, so we can find this value. So please take this down and let me know if you have any questions or any doubts or anything or whatsoever, all right? Example. So this question says Jasmine needs to get a load of products from home to the market, which is 15 kilometers downstream. So I believe these terminologies are familiar. So it is a river, downstream is going down or on the way down, and upstream is on the way up, which is 15 kilometers. There is a current of 8 kilometers flowing downstream. So that means whatever the river that is flowing at a speed of 8 kilometers per hour. So we have one object, which is the river, right? So we can call this 8 kilometers per hour as the velocity of the river, right? And this is not mentioned with respect to what, so you should understand that this is with respect to the Earth, right? So Jasmine's launch can travel at 25 kilometers per hour in still water. So there is this term that you should understand, which is still water, right? So they say that the second object is launch, and the common frame or Earth is the common reference frame. So the second object that we are talking about in this question is launch. And the velocity of launch with respect to the water. Why is it respect to the water, not respect to the Earth? Is because it says in still water. So there is a simple thing that you should understand. When you say velocity of A with respect to the B, this object with respect to, or which we are referring as with respect to, should not be moving. So this is at rest, right? So you should understand that concept. So whenever you refer some or refer a velocity with respect to another velocity or another object, whatever the object that you say it or you define it as a reference frame should not be moving. So in this case, they say in still water means the water is not moving. So you should understand that the launch velocity with respect to the water, that means the river and the water are the same thing that we are defining, is nothing but 25 kilometers per hour, right? So the first question is find Jasmine's velocity related to the water as she travels down to the market. So we are trying to find the launch velocity with respect to the river. That means the water, right? So the LR is nothing but 25 kilometers per hour, right? Then we have to find out Jasmine velocity with respect to the ground, which is the Earth, right? So those are two different terms that you should familiarize with. So I mentioned that we usually have three objects, right? So the third object, you have to pretend like you are inserting in the middle. So what you are going to get is VL, the third object is R plus VR. So you cannot change the order of these letters because as you change the order of these letters, you should understand there will be a negative sign in the middle, I mean in the front, right? So you should not be changing the order. So VLR is 25 and VRE is 8, right? Which is 33 kilometers per hour. So these are, both of these people are traveling downstream. So we have simply added these values. So whenever you are doing a vector addition or vector summation, you should make sure that the direction is considered, right? So this is also downstream. This is also downstream. So those two are positive values, so they were getting added to each other. Then how long it will take for Jasmine to reach the market? So the velocity is distance divided by time. So time is nothing but distance divided by the velocity. So the distance is 15 kilometers per hour, sorry, 15 kilometers. The speed at which they are traveling is 33. So 15 divided by 33 is going to be the time that has taken Jasmine to travel downstream. I don't know where I put my calculator. Oh, where is it? Okay. So 15 divided by 33 is 0.45 hours, right? So the next question is, find Jasmine's velocity as she travels back home. So that means you should understand that the river is flowing downstream, but Jasmine is trying to come upstream, right? So in that case, VLE is still VLR plus VRE. VLR is like this, right, which is 25, and VRE is downstream, which is 8. So I mentioned that if going right is taken as positive, going left should be taken as negative. So this is minus 25 plus 8, which is minus 17, right? Kilometers per hour. So this minus is telling you that this is going in the upstream because we have taken the downstream as positive. So this minus is telling you this is upstream velocity. So they are going back up to the home, right? So it is a similar thing. Now that you know the velocity, you can find the time, because upstream also it is going to cover 15 kilometers divided by 17. So 15 divided by 17 is 0.88 hours, right? So if they ask you what is the total duration of her travel from home to the market back home, is 0.88 hours plus 0.45 hours, which is 1.33 hours. So that is the total duration of her travel, right? If you have any questions, please ask. Or if you didn't understand any part of this, please ask. So kinematics is basically finding or defining the motion of the objects, right, under uniform acceleration. So that is very important. So this kinematics you can only use under uniform in the sense, not exactly uniform, let's say constant, because constant and uniform have two different meanings, right? Constant acceleration. We will get back to what that means, but for the time being, just hang on, right? So in kinematics, so let's assume that I have an object that is already traveling with a particular velocity. And if I push or if I pull by applying a particular force, what would happen is this object will start to move faster, right? So the velocity of that object will increase. So we can say that the velocity that this object had here as the initial condition, so we will call it Vi, and the velocity of this object as of here, we can call it the final condition Vf. And this would have taken some time. Increment in the velocity doesn't happen like in a flick of a second, but this would have taken a particular time. I do not know how long. So let's say it has taken t amount of time for the velocity to increase. So we are relating some physical parameters. One physical parameter that we are relating is velocity. The other physical parameter that we are relating is time. So there should have been a reason for the velocity to increase, and the reason why the velocity has increased is acceleration, right? So you should understand, if you accelerate, the velocity should increase, right? So that is the definition of the term acceleration. And the opposite of acceleration is what we call deceleration. And when deceleration happens, the velocity goes down. Or the other term for deceleration is negative acceleration, right? So the negative means it is doing the opposite of what it